Hey guys, Wally Renee here, and I'm going to do a little tutorial on the anterior adhesion bridge. So the first thing that you're going to notice is a profound size discrepancy here where tooth number 9, the mesial to distal width is really way out of proportion compared to tooth number 8. We're needing to free up some room. So in this instance, we put it back. We reduce some of the mesial tooth number 8 and put it back into Smile Design just to make sure that our sizing is right. So before anything, just verify sizing. And of course, we milled out lithium disilicate here, Emax, and we used the medium translucency block, and there's the final product. So how did we get there? Well, there's a little bit of eccentricities with this design process that you have to understand. So let's kind of go through it really slow. The first thing is for your pontic, you could make it a pontic or a crown. I actually like to make it called a crown, and I pick Preop library for that because we're going to mirror image. The tooth that's going to get the wing, you're going to call it a veneer. Okay, so then you're going to link those two together using the link tool by clicking each one. And then we're going to go ahead and point out a few things on the scan here. The first thing that you need to know is you have to have a pre-op scan if you're going to do mirror image. And if you forgot to scan it, you could always right click on the lower arch and drag it up and copy it into the pre-op library, so you could do that. But okay, so once we are sure that we have a pre-op scan and everything, we have to set the orientation for each one of these individual units. And so for tooth number 10 here, it's kind of a straight down view. For tooth number 9, it's going to be where the crosshairs of this compass are perfectly in line with the long axis of tooth number 9. So now we're going to use the trace tool and circumscribe the margin, kind of guessing at this point where that facial CEJ or emergence profile is going to be. And you could see that lip on tooth number 8 that I should have smoothed out from the interproximal enamelplasty. One little tip when you're moving the margin of the ponic site is to bring the whole model up to the top bar right there and line it up with the kind of the central and lateral of the contralateral and adjacent teeth there, and let that margin fall right on that line. The other thing is extend kind of a squarish marginal area where your connector is going to be, so that's a broad contact there. So now here we are in the pre-op editing tab, okay, which is still in your margin tool. And we're going to trace the contralateral tooth and make sure there's a green check mark down there on the contralateral. If you don't have this checked, it could be a bad day because it's hard to go back and then recheck that for some reason. So now we circumscribe the entire tooth number 8. And now we're going to mark our margin on. So we have the ponic site marked, we have the contralateral tooth marked for that, and now we're going to mark the wing tooth. So you want to extend the connector, usually 1 millimeter facial to mid-proximal. I was a little aggressive there, and you're going to see that's going to come back and haunt me when we look at path of insertion issues. And you want to extend it as far down as the tissue you could get without getting into a major undercut, which oftentimes necessitates you to do like a guide plane on the tooth as well. Now, you're going to go to the Plan tab, and what you'll see is a perfect mirror image shell, a skin of the contralateral tooth, number 8, that you could then manipulate, rotate, translate, and move into space. So here I am now just kind of positioning that mirror image shell of tooth number 8 into the 9 ponic space the way that I see fit. And I'm not going to really do much with the wing tooth. I'm just going to actually let Autogenesis do that. It does a pretty good job at these little wing veneers. So I didn't even use the Plan tab. I just kind of hit next. Now I'm going to thicken up that wing. A little rule of thumb is you want to try to keep it green. The darker the green, the better. And it's okay if you have some yellows and oranges here or there. Okay, so we're looking straight down here, and you will notice you have an emergence off of the interproximal mesial into the ponic space. You kind of want that. You want that overlap there, that kind of overhang. So now we have ready to generate this ponic site. And we're just going to grab the red tooth and bring it above the occlusal plane of the incisal edge of the green tooth. And this is the initial proposal here. And you're going to see it's going to be a pretty close mirror image to the contralateral tooth. And now, of course, we still have all our favorite tools that we could use to manipulate and rotate, smooth, and everything like that. So Control-Alt will kind of, at the same time, will kind of make the tooth what they call Medusa view. It's going to be stone color, and I really like designing like this because the blue is just very distracting to me, and so I like to turn everything this stone color. And here I am just using rubber tooth, rotating everything around, manipulating, and don't spend too much time changing things because it is a mirror image and it's going to be really close. All right, so we're going to just alter the emergence profile a little bit. We're extending that lingual perhaps a little bit further than we normally would at that connector site to make a broad, a more wide buccal-lingually area for that connector to adhere to. And we're just going to alter the shape just a little bit because the more you mess with it, the more you lose the mirror image. So if I go in now and smooth too much, I'm going to start to lose some of the little eccentricities like the nick and the incisal edge and things like that are going to really, I think, be essential to make this case all that much better. So less is kind of more when you're using mirror as it relates to the design process. Here I'm just smoothing any kind of areas on the intaglio surface of the ponic site that may have extended down into the tissue. Now I am just smoothing that contact area a little bit where the connector would be. I'm just taking my sweet time. This is not, I actually had to go back and slow this whole thing down for you guys because clinically this is literally a three-minute design for me. And I'm struggling to even figure out what to say to help you guys with this design. It's so easy to me. And I'm not bragging about that. I think the software just makes it that easy with the mirror image and everything like that. So I'm going to try to find some things that maybe could kind of be hiccups to the new user that they might not think about. And that mostly relates to mill path issues and path of insertion and things like that. So right now I'm just kind of taking my sweet time using the dropper to even create a little bit of a rolled emergence there that I could always go back and thin out with a handpiece. Guys, remember, there's nothing sacred about a block that comes out of a mill. I want you to get used to touching it with the diamond burr. I always just at least scratch the whole entire surface just to, even if I don't need to do anything, just get used to playing with ceramic. Hitting it with your handpiece. Okay, here's one of the things I really need to mention. The pontic is dragged through the connector wing and into the adjacent tooth, and it will mill like that, and then it won't seat. So if you're thinking you don't need to check that area, you absolutely have to check that area. Once again, the pontic tooth number 9 was stretched through the mesial wing and extended into the adjacent tooth 10, which would cause binding issues. Okay, so that's the first thing that you probably wouldn't think to check that you need to check, because I'm sure you're thinking that you should have just checked the proximal contact of the mesial of number 9 and as it related to 8. But the reality is this distal contact here as it relates to this connector is even more important. You have to make sure that you're not overextending that through that wing area there. All right, so we're just going to rotate around and look from all areas, make sure we don't have any weird things that we notice that we want to change. Once again, always trying to make sure that you spend special care around the way that the ponic is emerging from the tissue there, using dropper and things like that. Okay, as you can see now, we have a perfect mirror image of the contralateral tooth. Our wing is formed. We have good, strong and long connector. We're going to fine tune our proximal contact. Now for me, I like a broad anterior contact that's going to be like a Hawaii Oasis green teal color, a very pretty color. And because I left that kind of shark fin on the, the contralateral tooth, I'm going to have to deal with that. Hopefully you guys wouldn't do something like that. Now let's go now to the mill, and this is well, the design's done, and this is kind of where the hard part happens. There's a few little things that you have to consider with the 3-axis mill and path of insertion and things like that. Firstly, we're going to reset the orientation to accommodate the best mill path now. So the first time we set orientation was for the best design. We put in the crosshair. Now we don't care about those crosshairs. Now we want to be able to look down and see both of our margins of our ponic and our wing in completion at the same time from the path of insertion that we're going to mill at. Once again, this is the dual path of insertion technique. You are now already finished with your design and all you care about is mill path. And I cannot see my facial mesial margin. So I'm trying to rotate. I have to be able to see my full ponic margin, and I have to be able to see the entirety of my facial, my whole entire margin on site 10. So once again, I'm going back, and I'm even going to go ahead now and stretch my mesial margin there on my wing site and move it a little bit more lingual because it's into an undercut. So using move margin here, which preserves the design. And all I'm doing is just dragging that margin using, once again, in the design tab. We're not in the margin tab. If you move it in the margin tab, you lose the design. So, but in the design tab, we're moving this margin. Now we're going back to our orientation. And I'm rotating this. And here, I think I have it. I could see maybe just a little bit more there. I could see now everything. So look, I could follow that line pretty much all the way around. Now, see, I lost the mesial, the ponic there. So this is just a little game that you play. If you want a gorgeous fit that looks pressed, this is kind of the games you have to play sometimes with a 3-axis mill. So now I think we're perfect now. I hope you understand what we're looking at. That's the same thing for fixed bridges, for anytime you have multiple units, that's going to solve all your bridge issues. Yeah. So now we're going to go ahead and just simulate. So we're going to sim this out. And we're going to sim it. I want to be able to mill this in standard mode. I don't want to spend 55 hours with the detailed mill. It's beautiful for whisper thin veneers and things like that, but for this should just be a standard mill. So now we're simulating this mill, and what it's doing is it's virtually grinding this restoration out. So we went ahead and hit sim. Now I'm going to look, and immediately I notice I have some weird things. I'm not so concerned about the fin that is on the wing. I'm concerned that it kind of bonded the ponic to the block like that. That's going to be a bad mill. So I'm going to go ahead now and move my sprue. And I like to stay off the intaglio, so I'm going to, that's not a bad spot there. We could have tried that, but there's no C14 option. I want to keep a C14 block so I don't have to waste any kind of expensive bridge block. Boom, to a C14. I'm going to re-sim it out in standard mode and see what we get. Okay, there is a little wait, especially here because I have it set to quality simulation, which means it's going to take a little longer. Sims are, I sim everything. It just saves so many problems. Now, some of you might be like, well, what about that giant, you know, swordfish looking narwhal beak hanging off of this thing? That doesn't bother me. This looks like a good mill to me. Okay, I'll zip that off, take that off. So now I'm ready actually to send it. But before I do that, I want to show you guys there's two simulation modes, speed and quality. Make sure you're on quality. I'm going to actually check fit here because there's something that you guys need to understand with veneers, and this wing is considered a veneer. And we're actually pretty fine here, but I'm going to go ahead and purposefully mess it up. What I'm looking for is binding spots. And you're always going to get binding spots at the inside, so I'm going to show you what I mean by this. This is considered an acceptable amount of binding for this wing. When you look under the intaglio surface of that, typically there's going to be massive binding right where it rounds this corner here. Okay. especially if you don't know how to set up the cement gap and margin ramp for these types of restorations. I'm going to show you what I mean. So I'm going to go back to design, and I'm going to go finagle with some things that you might not know to finagle with. We're going to go immediately to and we're going to set this thing kind of the way that I always like to do this is a pretty big cement space for the wing, so about 200 microns, and then you want your margin ramp to zero for the margin ramp, okay? So you want to avoid all binding spots, 0. Don't forget that, guys. It's super important for these types of restorations, and things like no prep veneers as well, you want 0. All right, so now we're going to go back, and we're just going to go ahead and sim it out real quick so I can show you the beautifulness of that fit, and then I'm going to maybe try to show you what not to do with those, and so you can see what a bad one would be as well. So now we're back to the sim, just a quick little simulation here, and let's see what we got going on. This takes forever. This is real time, super slow, nothing's sped up. All right, let's take a look under the intaglio right here. Yeah, look at that. It is money cakes. There's no binding spots. That tiny little speck is no worries to me. We're going to section it right down the middle of that wing, and we're going to drag this up and look at the uniformity of space there, even as it wraps around that mesial. Perfect spacer all the way throughout. No binding spots anywhere. This is going to slide right in like butter. That's what I'm talking about. That's a good mill right there. So what does a bad sim look like, you know, when you're looking at these little delicate little wings? Well, let's maybe go back and change to the settings to something bad so you could see. This way you understand, like, you know, what is too much binding, because that little speck right there, to me, I know that that's not going to be a problem, something tiny like that, for an adhesion bridge. So let's see. I'm going to take you back to the design tab right now, and I'm going to alter with the settings so that you could see some bad stuff. So, like, you know, basically increasing your marginal ramp is going to be a bad thing for something like this. Your marginal ramp is how much of the ceramic is touching at the margin, or what it perceives to be a margin. Now on a wing bridge, there's really not a margin. There's no prep surface, and so it can be tricky if it wants to bind at an area that's not even a real margin. So if you ramp that up to, say, you know, I don't know, 0.8 or whatever, and you bring this down to 100, like you would think, oh, 100 microns or whatever would be phenomenal for a veneer. You're gonna see really quick that when we go to the mill tab and we sim this out, you're gonna have these megalithic, giant, just butterbean sized binding spots. So if you take a look here, I'll rotate this. I'm just doing the sim now, once again, running through a quality sim here, so we're gonna be able to see the kind of predicted fit of this restoration. I recommend that you guys do this for everything when you're starting out. Just predictively check. It's going to solve a lot of problems. You're gonna find that. Look at this. See all those suckers? That fin, right at that curvature of that mesial, and all those wicked giant binding spots there are gonna just. Your wing is going to be wide open. You're not going to understand what's going on. You might even snap it during trying to figure out how to get it seated. If we cross-section plane here and we drag this up, you're going to start to see that the actual restoration is milled into the tooth structure, and it will just cause you so many nightmarish headaches. You're not going to understand what's going on. So this is why there's little details that are really important. So here we can see we could start to get binding right there at that corner, but if I lift it up, we're going to see now that we're going to actually cut into the tooth by a good like 500 microns here. So we can see if I rotate, and I can just kind of show you the silhouette of that unprepared tooth there, and you could see exactly how much material is in that. So anyway, I hope you learned something today that might be helpful for these adhesion bridges. Now, we are going to have a whole entire CE in a box kind of thing geared towards adhesion bridges. That's going to be about 6 hours of CE credits. So more about the science and the prep, and if you do need to prep, and the materials and things like that. So look forward to that coming from our UNUM yet, but in the meantime, this should hold you off.